Hello, so this is AQA Pure Core 1, Summer 2015, question 2. So this says the point P has the coordinates root 3, 2 root 3, and the point Q has coordinates root 5, 4 root 5. Show that the gradient of PQ, so we want to know the gradient, can be expressed in the form n plus root 15, stating the value of the integer n. So integer just means whole number, so this needs to be our whole number. I mean, this question's quite cruel because it's kind of overlapping topics in some respects. The third questions are usually very much by themselves and not connected to the gradienty, graphy kind of questions, but you know, this year they were a bit cruel, so let's go for it. We know that, well, I mean, alarm bells should be ringing initially anyway, because we've got, this is the form that they want the answer in, root 15, and we know that 5 times 3 is 15, and they're the numbers in the roots, so just think about little things like that. And we know that if we have 2 points, then to work out a gradient, we use the formula m equals y2 minus y1 divided by x2 minus x1. So let's call Q the P, x2 and y2, and the Q x1 and y1. Okay, so let's just sub these coordinates into this equation first of all. So m equals y2, so 2 root 3, minus y1, which is 4 root 5, divided by x2, which is root 3, and y2 minus y2, minus x1, which is root 5. Okay, so we know that in these questions where this needs simplifying because we need it in this form, so this is the gradient technically, this is the answer, but now they want us to manipulate it and make it into this form. So what we need to do is remove the square roots from the bottom, and we do this by timesing both the top and the bottom by whatever the reciprocal of this is. And what that means is whatever, like this, but with the opposite sign in the middle, which is the less technical way of saying it. So root 3 plus root 5. So let's times the top by root 3 plus root 5 and the bottom by root 3 plus root 5. Put that in brackets so it's all nice and neat. And this just requires multiplying out like you would if there weren't surds there. So let's do this. So we have m equals 2 root 3 times root 3. So if we times root 3 by root 3, we get 3. Because if you times just to one side here, root x times by root x equals root x squared, right? So if we have root 3 times root 3, we're going to get root 3 squared, which is 9, and root 9 is 3. Okay? So 2 root 3 times root 3 is 3 times 2. Do you see that? So 6. Okay? So now minus 4 root 5 times root 3, that's going to be minus 4 root 15. Because, just a side note again, if we have 4 root 5 times by root 3, that equals 4 root 5 times 3 equals 4 root 15. And here's our root 15 that we want to see really, because That's how they want to see the answer. Okay, let's keep going. So we now have 2 root 3 times root 5. So we're going to go a bit quicker now. So now we've got 2 root 15 minus 4 minus 4 root 5 times, where have I gone right here? 2 root 3 times root 3, 2 root 3 times root 5. So that's 2 root, oh, this is where I'm confused because this is a 2. So this should be 2 root 15, and then we've gone, oh no, that should be 4. Sorry, I'm very confused. This is why it's really good to just go through these really slowly when you're in the actual exam, because it's ridiculous that the mental arithmetic can completely knock you off. So now what we're left is minus 4 root 5 times root 5. So again, that just ends up being minus 4 times 5, which is 20. And then the denominator, so this is still 4, but let's just leave that out now. The denominator is minus root 3 times root 3, 3. Minus root 5 times root 3 is minus root 15. Minus root 3 times root 5 is plus root 15. And minus root 5 times root 5 is minus 5. So then we have, see, this cancels. That was the aim. So now we don't have any roots on the bottom of this equation. And now we find ourselves with 6 minus 20, which is minus 14 minus minus 2 root 15 divided by minus 2, because 3 minus 5, which leaves us with, we can cancel out this minus 2 and make it 7 plus root 15. So the answer N is 7. I hope that was helpful, and thank you for watching.